Electric motors has its roots back to 1821 where British scientist Michael Faraday managed to conclusively demonstrate that motion can be generated from electricity via electromagnetic means. Since then, electric motors have been a very important piece of technology for mankind in many sophisticated machinery. Electric motors are very important today. They can be found in industrial fans, blowers, pumps, and even in disk drives. While its application is vast, it is actually a relatively simple piece of equipment. Electric motors works based on the principle of electromagnetism. A simple experiment of connecting a wire into a pool of mercury and sandwiched between a U-shaped magnet can demonstrate the principle behind the electric motor. In secondary to science, we have learned that a current-carrying wire can deflect the needle in a compass. Hence, a current-carrying wire must have a magnetic effect. This magnetic effect, together with the magnetic field generated by the U-shaped magnet, creates the repulsion effect that kicks the wire, causing a motion. This principle is somewhat similar to how two magnets of same polarity would have been. Repulsion. We are also taught by our mentor, Madam Lee and Mr. Eugene, how to determine the direction of the wire's kick. It can be determined by the use of Fleming's left-hand rule. The middle finger tells us about the direction of current, while the index finger tells us about the magnetic field. And lastly, the thumb tells us about the direction of force. With these knowledge and concepts, we are ready to investigate the factors that affect the speed of rotation of an electric motor.
Let me introduce you to this experiment setup. This is a whole setup. These are the three batteries. They are connected to the rheostat. Then the rheostat is then connected to the paper clips. The paper clips are supporting the electric the coils for them to spin. Then when you put the coil across, the circuit will then be completed.
Number of turns of coil as variable. We took the average reading, the time taken, and the frequency of 6 coils in order to determine the coil which has the highest frequency and the shortest time taken. We noted that as the number of turns of a coil increases, the speed of rotation increases. The graph shows that 12 is the best number of turns before speed of rotation starts to decrease. There are two explanations as of why speed of rotation starts to decrease if the number of turns exceeds 12. First, as the number of turns increases, the weight of the motor coil increases. Hence, the increase in the weight of the coil outweighs the increase in the electromagnetic force spinning the coil. Thus, the speed of rotation slows down. Second, as the weight increases, the contact force between the jutting edges of the coil and the holders increases. We have learned that friction force increases with contact force. Hence, the stronger resistive force occurs to slow down the spinning motor coil. Diameter of the coil as a variable. After fixing the number of turns, which is 12, we alter the diameter. We notice that as the diameter increases, the frequency increases too and the time taken decreases. The data at graph 2 suggests that as the size of the coil increases, the speed of rotation decreases. This trend does allow us to confirm that the fact as the size of coil increases, the speed of rotation of the motor coil decreases.
Error analysis and precaution. The size of current. The size of current flowing in the circuit should be limited to the most 1 ampere. This is because if a large current is flowing through, sparks will be formed at the two jutting edges of the motor coil. Since the oxide layer is an insulator of electricity, it may cause a decrease in the speed of rotation of coil and affect the accuracy of the reading. Thus, constant sanding of the jutting edges are required by using sandpaper to remove oxide layer.
Irregularities of coil motor. The two ends jutting out from the coil should be perfectly straight, but it is not possible in reality. Thus, this will result the rotation to be irregular as well. We try to reduce the source of error in two ways by taking two readings of time oscillation in the data line, repeating the experiment, and taking an average reading of the two sets of readings to find the period of oscillation.
Based on our data and analysis size of coil and number of turns of coil does affect the speed of rotation of the motor coil. As the number of turns of coil increases, the speed of coil increases. We have managed to verify this claim experimentally. However, limit to this, the number of turns increases, the weight and also the weight increases. So the speed will slow down. It is not necessarily a disadvantage to have larger size of coil. From our mentors, when the size increases, it allows the motor to generate more force. Hence, For building a well-functioning electric motor, the number of turns, diameter, weight, and amount of current flowing through the coil affect the speed of rotation. In the next step, our project will be to build a motor that can run a device.